We're asked to find the difference between the area of the shaded shape and the area of the triangle. Now, there is a shortcut to this question, which I must admit I didn't notice myself, but the difference is essentially going to be this blue area minus this purple area. And the reason for this is that the shaded is going to equal, like the shaded outside plus the shaded inside, but the shaded inside will equal the triangle minus the purple area. And if we then find the difference between the triangle and this, you can see that we simply get the shaded outside minus the purple. If you don't spot that, I will talk about how you could do it by working out the area of the triangle along the way or afterwards. So let's deal with the shaded outside. Well, we've got a sector here, and this is 60 degrees, so the area of the sector outside is going to be 300 over 360 multiplied by pi r squared. Because the side length is 2, then this length here, for example, is 1, and the radius of the circle is a half. So pi times a half squared. Now we've got 3 of them, and we can just work this out. So we can cancel out the zeros. We can cancel this 3 out with the 36 partially to give 30 over 12. This becomes 15 over 6 times pi times a quarter, which is 15 over 24 pi. Brilliant. For the purple circles, it's actually going to be a little bit easier. We're going to get pi times a half squared for the area of one of the circles, but I want a semicircle, so I times by a half, but then I times by 3, so it's going to be 3 over 2 times pi times a half squared. This becomes 3 over 2 times a quarter, or 3 over 8 pi. And we're basically there then. So the difference is going to be 15 over 24 pi minus 9 over 24 pi, which becomes 6 over 24 pi, or pi over 4. Okay, well done if you spotted that shortcut. Really nice. All right, now how do you do this question if you don't spot this little bit of information? Well, we're going to have to work out the area of the triangle. And there's 2 ways to do this. First method, for an equilateral triangle, or any triangle in fact, is to use half AB sine C. It's just for an equilateral triangle, it simplifies quite nicely. You might never have seen this before, in which case you're not going to be able to use this method. But I'm going to talk about it, and I'll talk about another thing you could do. So a half times 2 times 2 times sine 60. Okay, see, this method also requires that you know your exact trig values, which in this case is root 3 over 2. So the half and the 2 cancel, the 2 and the divided by 2 cancel, and we get as our answer root 3. If you don't notice that, you can still do it by splitting the triangle down the middle, because now the base is 1, and I've got 2 here, so you can use Pythagoras. 2 squared minus 1 squared square rooted is root 3. And then this time it's going to be a half times the base, the full base, 2 again, times the height, root 3, which again gives us root 3. So the only extra bit is that we would work out that we've got root 3 for the triangle. And then for the shaded, it's going to be the 15 over 24 pi for the shaded outside. And then for the inside, it's going to be plus root 3 minus that 3 over 8 pi from before. So you can see now, when you then find the difference between these two, this cancels, and you're left with the same answer as before. I'm just trying to explain, if you don't spot it, it just naturally cancels out in the calculation. You just spent a bit of time working out root 3. Okay, well done on this question.